In this video, we will kind of continue our discussion on dividing polynomials, concluding with the remainder theorem and the factor theorem. So these two tools will help us evaluate polynomials really easily. It'll help us determine some of the behavior, whether or not something is a zero of a polynomial, and a couple other kind of useful techniques for looking at polynomials. So we'll start with a little bit of motivation. We'll use that to look at the remainder theorem and the factor theorem. So let's divide the polynomial x squared minus 4 by x minus 3. And I want to put our attention on what's going on with the remainder when we do this. So we know how to do this. We'll set up 3, and then we need 1. We need a placeholder 0 for our x, the first term, and then we need a negative 4. So we drop the 1 down. 3 times 1 is 3. 0 plus 3 is 3. 3 times 3 is 9. And then negative 4 plus 9 is 5. Okay, now I want to point something out to you. What if we had just plugged 3 into the polynomial? Such like p of 3 equals 3 squared minus 4, which equals 9 minus 4, which equals 5. You see what's happening here? So it's not by coincidence. We've talked about the division algorithm like this, like p of x equals the divisor times the quotient plus the remainder. Now, if the divisor takes the form x minus c, let's substitute that in. So we have x minus c times q of x plus r of x. If the divisor takes this form, then the remainder must be a constant, and we can call that constant r. So let's substitute r for r of x. So we end up with this. Now, if we're plugging in c into the polynomial, p of c equals c minus c times q of c plus r. So this term just goes to 0, and we're left with r. So that's a kind of quick and dirty proof for why this is true. If we're trying to divide a polynomial p of x by a polynomial of degree 1, then the remainder will be just p of c, where the constant in the linear term is c. So of course, if we had something like x plus 3, we have to set that equal to 0 and then solve for x appropriately. We can use the remainder theorem to help us find out if this is true. So we could say, like, in this example, we know that x equals 2 would be one of the zeros of that polynomial. So p of 2 equals 2 squared minus 4, which equals 0. So this is true, right? And then we know that c is a 0 of the polynomial p if and only if x minus c is a factor of p. And we know that it's a factor of p whenever the remainder is 0. So these kind of two ideas are very related. That is, the remainder theorem and the factor theorem. So the remainder theorem states that if the polynomial p of x is divided by x minus c, if the polynomial p of x is divided by a divisor that takes the form x minus c, then the remainder is the value p of c. And the factor theorem states that c is a 0 if and only if x minus c is a factor of p of x. So we can use the remainder theorem and the factor theorem together to help us find out if a particular number c, is a 0 of a polynomial p of x. Namely, if we say that c is a 0, which then it must satisfy p of c equals 0, and that's the remainder theorem. This is kind of our check to see if c is a 0. Then x minus c is a factor of p of x.